Okay, so let's look at some of the cases in which we find the nature of the roots of the equation. So basically we know that if the equation is a simple ax squared plus bx plus c equal to 0, then the nature of the roots can be found or can be identified by solving for b squared minus 4ac. And this can have different possible values. It could be that this is equal to 0, it is greater than 0, or less than 0. And if it's equal to 0, we have one real root. When it's greater than 0, we have two real roots. And when it's less than 0, it has no real roots. But in this problem, the equation is not in the form of ax squared plus bx plus c equal to 0. So as you can see, you have like three fractions involved in the equation. So before you identify b squared minus 4ac, it is important that you change x over x minus 2 plus 3 over x plus 1 equals 1/3 in the form of ax squared plus bx plus c equal to 0. So how do we do that? Okay, so what we can do is we simplify it. So let's copy it first. So x over x minus 2 plus 3 over x plus 1 is equal to 1 over 3. To make it, or to eliminate the fractions, we can multiply both sides of the equation by the LCD of the fractions. And working with algebraic expressions, the easiest way to get the LCD is to simply get the product of the three. So I have x minus 2, that's for the first fraction. I have x plus 1, that is for the second fraction. And I have 3 for the third fraction. So this will be multiplied in both sides. So we write x minus 2, we have x plus 1, and we have 3. Okay, so this is what will happen. So when we multiply, we distribute. So if I multiply this on the first, then that would mean that the x minus 2 will cancel with the other x minus 2. So what's left here will be the x, the original x, multiplied to the remaining factors, x plus 1 times 3. And then when we multiply this time to 3 over x plus 1, so x plus 1 will be cancelled by the x plus 1 in the factor. So we now have plus 3, so that's your 3, and then multiply to the remaining factors. The remaining factors will be x minus 2 and 3. So we have x minus 2 and then times 3. Okay? And then on the other side of the equation, if we multiply x minus 2, x plus 1 and 3, so this 3 will cancel the denominator 3. So these remaining factors will be multiplied to 1, which is basically x minus 2 and then x plus 1. Okay? And then we continue by simplifying the equation. So this should be equal to, so we can work on x and x plus 1. So we have x squared plus 1 times 3, and then plus 3x minus 6, then you have times 3, and on the other side we have the product of this should be x squared minus x, then minus 2. Okay, so just make sure that you expand this properly. Okay, it should end with x squared minus x plus minus 2. Okay, you still have several expressions to simplify, so you can now distribute the 3. So 3x squared plus 3, and then on the second you have 9x minus 18, and then equals x squared minus x minus 2. And still, just continue working on the equation. So you have to combine this. You have 3x squared, and then you can have the 9x, and then 3 and minus 18 should be negative 15, equal to x squared minus x minus 2. You're almost there, so make sure the other side of the equation is equal to 0. So you subtract both sides by this, so the other side will be 0. But on the left side, so aside from 3x squared plus 9x minus 15, you get to have minus x squared plus x and then plus 2. Again, that is if you subtract both sides by x squared minus x minus 2. Almost there, so just continue working. So combine all the x squared, combine all the x, and combine all the numbers. So I can have now these two together, 3x squared minus x squared, so that's 2x squared. Then I work on the x, so I have 9x to combine with x, so that would mean plus 10x, and then I have negative 15, and 2 is negative 13, so we have minus 13 equal to 0. So as you can see, the fraction that is given as x plus 1 as x over x minus 2 plus 3 over x plus 1 equals 1/3 is now reduced into the equation 2x squared plus 10x minus 13, which follows the form of ax squared plus bx plus c equal to 0. And in this case, our a is equal to 2, our b is equal to 10, and our c is equal to negative 13. So from here, you can now compute for the value of b squared minus 4ac minus 4ac, and then we check what will be the value. So b squared is 10 squared minus 4 times a is 2 times negative 13. So let me erase that. So negative 13. Okay, so this is 100, and then minus 8 times negative 13. When you multiply 8 and negative 13, you should get 100 plus, that's 4 and 2, 104. And this is equal to 204. So the last thing that you need to check is what type of number is this. So is it greater than 0, less than 0, or equal to 0? And that's when you give your interpretation. But since 204 is a positive number, so it's greater than 0, greater than 0 means that the given equation, so our conclusion will be the given equation has, so when it's greater than 0, has 2 real roots. So that's how you identify the number of roots or the nature of the roots. Okay, so I hope you understand how we got the value. So just keep in mind that when the equation is not in the form of ax squared plus bx plus c equal to 0, you manipulate the equation and change it into the form ax squared plus bx plus c equal to 0. The moment it is changed into ax squared plus bx plus c equal to 0, it becomes a very simple problem in that you know now the value for a, the b, and for the c easily. Okay, so don't forget the nature of roots depending on the resulting number. When it's greater than 0, it should be 2 real roots, less than 0, no real roots, equal to 0. 1 real root, which is basically 2 real roots but are the same. Okay, just a final note, we forgot to specify it, because although we in some cases it should be already an agreement that when we say 2 real roots, they are different. But just to make it exact, so when we say 2 real roots, what we mean is we have 2 real and distinct. So distinct means they're different, so distinct roots. Okay, now just to be, because the technicalities in identifying it, when they say 2 real roots, although they should be different, it's better if we say they're 2 real and distinct. Okay, so that's it.